Hey guys, welcome. So today we're going to solve Leetcode number 17 called letter combinations of a phone number. So the problem statement is as follows. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. Okay, so that's the problem statement. And just like before, this is my first time seeing this problem, and I'm going to be solving this problem live, so please be patient with me. So let's first break the problem down. So I'm going to write down any questions that I may have regarding this question. So the first question is, what is the input? Okay, so let's list all of the questions that we should be answering as we try to solve this problem. So what is the input? What is the output? What is the brute force solution? Identify bottleneck. So once we come up with a brute force solution, what we should try to do is to identify bottleneck. I meant to say bottleneck. And finally, how can we optimize our brute force solution? Okay. Or simply we should say, how can we optimize? Okay. So right away, we are given, so let's look at this example. We are given a string, let's call it an string of number, and the output that we are getting out of this is array of strings. So let's call that ARR. Okay. So there's a little note here. Although the above answer is in lexicographical order, your answer could be in any order you want. Okay. So let's try to really understand this problem. So let's list our questions here. So a lot of times when you are in a crunch, what I try to do is I try to list any questions verbally into the comment section of the code, so that it'll help me process the information as I see it, or else you'll be in the dark and your mind will blank out. So for anybody who's trying to do interviewing live, I would highly recommend just talking through the questions, talking through any approaches that you may have in mind, and try to list them down in the comment section of the code, so that it'll help you process the problem statement. Okay, so let's read the question again. So I still don't fully understand this problem because I read it through so quickly. So we are given a string containing digits from 2 to 9, right? So this is like a telephone pad, essentially, in the olden days, right? So we have to return all possible letter combinations that the number could represent. So in this case, we have number 2 and 3. So let's look at this example. Right, so 2 and 3, the existing characters are A, B, C. So number 2 represents A, B, and C. Number 3 represents D, E, and F. Okay, so right away, since the problem statement states that 1 does not map to any letters, what happens when we get ones? So that could be one of the questions we ask the interviewer, for example. in this case, I'm assuming that 1 is empty. So I'm just assuming that nothing happens. We don't print anything out for once. Okay. What about 0? Okay. Also, the problem also stated that the numbers that we'll be getting are 2 to 9. So that also answers our question. So we are only getting numbers from 2 to 9. Okay. Since we sort of understand the questions, let's think about how we would do it in a brute force manner. So let's look at our example. So let's say we have 2 here. So 2 represents A, B, C, yeah. And we have 3, which represents D, E, and F, right? So what we could do is we can find, let's see, so another question that we should ask is, how do we know what is the length of our combinations? So in this case, because there are 2 numbers here, the length of our output strings as we generate the combinations is 2, right? So right away we know that if you remember from math, this is some sort of combination formula, n choose 2, right? I don't remember the formula exactly, but let's try to derive an algorithm that we can use to come up with a solution. Okay. Okay, so the algorithm that I can think of at the moment is to use a sort of a permutation algorithm, a swapping permutation algorithm, which I know for sure is O of runtime of it is O of 2 to the n. And let's see, why is that? Let's see, what can we do here? Actually, okay, I'm not going to try to derive the runtime just yet. So let's fill out this algorithm. How can we do it in a brute force manner? Let's not make any guesses here. So let's write out a pseudocode. So what we can do here is, so let me write this down on a piece of paper so that it may help me reinforce the solution in my mind. Let's see. Where's my pen? Okay, so let's think about it. So let's say we start with A, right? The next possible thing that we can start with is B. Okay, after B, then C. Oh wait a minute. We are looking. Okay, so we don't. So it's a combination with the other number, not with the letters of the number that we're looking at. So in this case, A, and the options that we can choose from are D, E, and F. So we can either have A with D, A with E, A with F. What about B, right? So B is the same options, D, E and F. Let's see, same with C. C is going to be D, E, and F. Okay, so this problem is pretty straightforward. It gets a little more complicated when you have 3 or more numbers. Okay, so let's think about that. So let's solve another problem so that it may help us think about the solution, brute force solution. So let's say we have 2, 3, and 4, and for this we know that, so let's get rid of this. Okay, so let's make this a little nice. Okay, so let's say for example we have 2, 3, and 4. We know that 2 corresponds to A, B, C. 3 corresponds to D, E, F. And 4 corresponds to G, H, I, right? So yeah, let's make this nice. It annoys me when even the comment, I like to make them nice. Okay, so in this case the walkthrough here is, let's see, for this case we have, so let's say we start with, another thing to note is that because this is a combination, the order does not matter. They still count for the same thing. So A to A and D, or D and A, are considered the same. I'm referring to this example, right? So it can either be A to D or D to A. Okay, so let's walk through this example with 2, 3, and 4 as our 3 digits. So let's say we have 2. So 2 is A. So let's say we start with A, right? The next possible thing that we can start from here is either D, E, or F. Okay, so now here is where it gets a little tricky. So now from D we can start from, so this solution, so the walkthrough is starting to show us some patterns. So it's starting to look like a tree, right? So some sort of a decision tree. So from D we can choose from G, right, H, or I. Let's see, right? From E we can choose from, let's see, from E we can choose from G, H, and I, and same with F, G, H, and I. Okay, so from the look of it, I think what we could do for our brute force solution is we simply, really what we have to do is we have a list of arrays, right? And each list contains the characters that correspond to that digit. And really all we have to do is we iterate through each character within the first array, iterate through each character within the second array recursively, and iterate through or the characters within the last array. So we recursively generate combinations that way. So essentially what I'm saying here is that we start with, so let's, for example, we start with the number 2. So number 2 is, we started with A, and then we recursively call on the second array, which is 3 here, which is the second array with, and then we start with D here, and then we recursively call the last array, which is 4. And whenever we are at the end of the list of array, so this essentially will turn into a 2D array. Okay, yeah. So once we hit the last list, then we print out our combination, and then we recursively then we recurse back to the second recursion, and then we'll start again with the second character of that second list, and that second list, and from that second character we'll recursively call on the last list again, and we'll do the same there. So okay, I know that my explanation is a little muggy, so why don't we try to implement this in code. Okay, so with this recursive algorithm, the runtime of this is O of, let's see, this is O of, because we have because each number corresponds to a fixed number of characters. So let's say that is n, and we are essentially doing almost like a breadth first search, right? It's almost as if we are traversing through all possible paths of a 2D array. If you right, so let's look at it this way. So looking at this example again, let's see. Let's see. Does this make sense? Okay. By the way, guys, I don't know if this. So let me try to write this out to see if it makes sense. So let's say BC, right? Let's see. I'm trying to see if this is like traversing through a 2D array. So let's say we start from A can go to D, right? And D goes to G, or D go to H, or D go to I. Okay. Yeah, so the runtime of this, if you imagine 3 different trees, so this tree here, which can branch out to 3 other nodes, and each node also branches out into 3 other nodes. So the runtime of this is going to be 3. So essentially 3 times, because we have 3 different roots, essentially we're originating from the first list here, A, B, and C, and each child, how do I say it? Each initial root has 3 childs, and the child, on the second level, each one of those childs also have 3 of its own childs. So in a way, what I'm trying to say here is that let's see, what am I trying to say here? So let me think about this. What am I? So essentially, this is 3 to the n, right? And why is that? Approximately, the runtime of this is 3 times 3 to the n, because we have 3 roots. It's really essentially is 3 to the n, right? Assuming each number corresponds to approximately 3 characters. And so if you were to look at this, each node has 3 childs, right? So let's say A, starting from A here, it points to here, it points to here, it points to here. So that's 3 childs. Same with B, points to here, points to here, points to here. Same with here, C, points to here, points to here, points to here. And then on the second level, each characters here as well contains 3 different childs. Here, 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 here. So in a sense, the runtime of this will be O of 3 to the n. Okay, I would say this is quite optimized already. There's really not much else we can do. What about space? So you might be wondering, what about space? Since we are doing this recursively, the space required will be O of n. Let's see, not O of n, m, which corresponds to where m is number of digits, right? So essentially, so this is potentially where we can optimize. Instead of doing it recursively, what we might be able to do here is to do it iteratively. So if we were to do it recursively, this is what we'll have. This is how much space it'll take, O of m. Okay, so now that we sort of have our brute force solution, so let's identify any inefficiencies, right? And what I was saying earlier is that with the approach that we just talked about, it takes O of m space. So now the question to ask is, can we do this iteratively? So let's write down our brute force approach here so that we are clear on what we are doing. So essentially what we're doing here is recursively, so our current approach is to recursively go through each list of characters print results when hitting last list. So let's see, can we make this more clear? So we are essentially, what we're trying to do here is recursively go through each list of characters. So let's say here A, B, C, D, E, F. And what we are also trying to do is from each character let me reword it. Okay, yeah, I don't know how to reword it better than this, so let's leave it like that for now. And you'll see how to do this in code. Okay, so now the question is, can we do this iteratively, right? Let's see. Okay, so at this point in time, what I would do is I would quickly implement the iterative solution, and then from there I will try to do it iteratively. So I'll do it recursively first. So here, so let's do it here. Right. Okay, so we are given digits, right? So the first thing that we should do is, okay, here, let's do it. So let's quickly implement our solution. Recursive solution. Okay, so let's do it like that for now. Okay, so the first thing that we should do here is we need to map each individual digit to a list of corresponding characters, right? So because this solution is a class, what we can do is we can initialize a static constant within this class. So let's initialize a map here, num to char, right? And then what this will look like is as follows. So let's quickly do that so that we can use this to look up our list later on. So let's do that. So here we have the F4, G, H, and I, 5, J, K, and is that L? I believe that's an L. And then we do the same for 6. So this is the tedious part. Thanks for being patient with me. And O, and 7. Okay. Let's see. P, Q, R, and S. 8, T, U, and V, and finally 9, right? Okay, so let's see. X, Y, and finally Z. Okay, so that's that. So now what we can do here is, so the first thing that we have to do is reference each character, each digit to a list of characters. So now what we have to do is num to list. So we just do another hash map here, and for each digit we'll perform a lookup. So let's see. Oh, another thing that we did not consider is what happens if we get duplicate numbers, right? I suppose nothing happens. We don't really care about whether a number is a duplicate or not. It'll still work if we were to do this approach. Okay, so let's see. You know what? What we want is a list of characters, right? Pen. Also, if for whatever reason, if D is not in So if for whatever reason we get to a place where a digit does not exist within our numchar, then we'll simply return an empty list. So this would be our edge case, right? Because the problem statement says that we are expecting digits from 2 to 9 inclusive. Okay, so now let's get back to this. Let's see here. So okay, so that should be it. So now from here on, we'll get a list of characters. So let's see if this even works in the first place. So let's do a quick check. So let's run this code. Okay, let's see. So we don't need that is. So let's try run that again. Numchar is not defined. Okay, numchar. Let's see. How do you do this? I believe we still have to call self, like so. Okay. So we still have to get. So we still have to reference from the self. Okay. So here, let's see. Are we getting the right list of characters? So A, B, C, D, E, F. Okay, seems to be right. So let's do a quick check here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, so now that we have a list of characters, all that we have to do here is call our recursive function. And really what we have to keep track here is list index. So let's call that list index. And what else? List. We also have to do list char. Okay, so now what we do here is first thing that we have to do is if list. Okay, we also have to keep track of our solution, right? Okay, so now what we have to do here is that whenever for our ending cases, I think that's the term. So whenever list index hits the length of the size of our list of characters array, this is when we will essentially save our solution here. So in Python, what you could do here is actually I'm missing something here. Okay. Right, I also have to keep track of current solution. So current. So okay. Right. So this is our current solution. So as we traverse to each level, we'll be appending to this cursor list. So here we can call empty string.join, which will create our string for that particular solution. Else for C in, let's see, char this index. What we'll do here is first thing that we'll do here is we'll append our current character here. Let's see. And we'll recursively call the next level. So we'll increment our list index by 1. We'll keep list char the same, cursor the same, and so another thing to keep in mind is that once we return from the recursion, we'll have to pop our solution. We have to pop our current character so that we can essentially reserve that spot for the next character that's coming up. And that should be it. And we're not returning anything here, so let's see. So now all that we have to do is we simply have to call this recursive so to generate our combinations. So list index is initialized to 0. We're also passing in list of characters. In this case we call it list ls. Cursor is as an empty list, and source is also an empty list. So let's do that. So rest will store all of our solutions here, and then now we simply have to return like so. Okay, so let's run this code to see if it works. Okay, self recursive so is not defined. Let's see. Oh yeah, we still have to reference self. Okay, any difference? What's going on here? Something's not right. We have a weird foreign character in here. What is that? Let's see. Let's try to print this out. For whatever reason we have a comma in here. Why is that? Could it be a mistake in here? Yep, I see a mistake in here. Let's see, A, B, C. Okay, I think that should be good. Z. So one of the commas managed to get into the quotes, one of the quotes of the character. That should be it. So let's see if this works now. Okay, any difference? Nope, we are good to go. So I believe this solution should be acceptable because this is our best conceivable runtime. And why is that the case? Because we have to go through all of the possible paths from each character to the lower level, to the next list, right? I hope that makes sense. So essentially, if you look at this, from A, we have to explore all of the paths, right? So A to D to G, A to D to H, A to E, D to I, and how many paths? Essentially, if you were to imagine this as a tree with 3 nodes per child, per node. So, right, so we have to explore 3 to the n nodes to get the results that we want. So, if I click submit, technically, oh, okay. Right, so that's a special case. Okay. Let's see. That's still not right. Let's see what's going on here. 2 and 3. What's going on? Why is there an empty string in here? Oh, right. Yeah, what am I doing? Okay, so there are a number of special cases. So the first one being what happens if digit is empty, right? Then we'll simply return a list of empty string. And another case is what happens if the digit does not exist within our lookup. Then we do the same here. So let's try to submit that. Okay. Wait, what? Oh, okay. Let's try again. Okay, so now, yeah. Okay, so whenever we hit unexpected cases, we have to return an empty list. Okay, so this solution was accepted. So let's see how we did. Okay. Oh, nice. So we are beating 99% of the submission. Memory usage not so bad. We are right around the middle. Okay, so I'm not going to further optimize the solution. I am quite happy with it. So thanks for watching and see you next time.